Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
Dynatrace is the leader in software intelligence, purpose-built for the enterprise cloud. It's the only AI-assisted, full-stack, and completely automated intelligence platform that provides deep insight into dynamic, web-scale, hybrid cloud ecosystems. That's why the world's leading brands trust Dynatrace to deliver perfect user experiences. Welcome to another episode of the New Stack Makers. I'm your host, Richard McManus. I'm Senior Editor here at the New Stack. The Kubernetes era has made scaled-out applications on multiple cloud environments a reality, but has also introduced a tremendous amount of complexity into IT environments. My guest today on the New Stack Makers podcast is Andreas Grabner, DevOps activist for Dynatrace, a leading software intelligence platform. He recently wrote in a contributor post for the New Stack, quote, "In the enterprise Kubernetes environments I've seen, there are billions of interdependencies to account for," unquote. Yes, billions. Andreas has written several other posts for the New Stack that make the case that AI technology is best suited to tame this otherwise overwhelming Kubernetes complexity. Another quote, "AI-powered observability provides enterprises with a host of new capabilities to better deploy and manage their Kubernetes environments," Andreas wrote in one of these articles. So in today's podcast, we're going to dig into how AI and automation in general is impacting observability today in Kubernetes environments. So Andreas, welcome to the show.
Thank you for having me on the show, and thank you for discussing a topic that is definitely, I think, not only dear to our hearts, but dear to everybody's heart out there that is currently trying to figure out how Kubernetes is going to power their next generation of applications. And there's a lot of stuff we need to take care of. And thanks for giving us a chance to chat about things that are important.
Absolutely. Well, so firstly, can you explain exactly what you mean by AI observability? Is this software that is powered by machine learning? I mean, how does this work exactly?
Yeah, I mean, first of all, I know that AI is just a very stretched term because everybody's using AI. We at Dynatrace, we try to be a little bit more specific. And when we talk about AI observability, our AI, and I think we go maybe into more detail later on that, we call it a deterministic AI. And what that really means, it at the core, it's about capturing a lot of data, but not only data where you have a lot of different data silos, and then you need to figure out how can I put the data on dashboards and make sense out of it. I think what we mean with AI observability, or maybe let's better call it deterministic AI observability, is how we can connect the data with context information, meaning which data relates to which other piece of data, from host level information, pod level information, container information, application and service level information. How does it all get work together, and how is it related? And then how can we use smart algorithms to figure out, in case there's a problem in one part of infrastructure, to figure out where's the potential root cause. Now, so what that really means, it's about how can we make faster sense out of data. There is some machine learning involved, but essentially it is crunching through a lot of data that is not only of great quality, but that is also connected. So we don't have to make a lot of guess games about, hey, can this over here be related to this over here?
Okay, and so how does that definition of AI observability compare to the standard definition of the three pillars, metrics, logs, and distributed traces?
Yeah, so I think obviously the three pillars are just what we do at Dynatrace as well, and what I think other AI solutions do out there. I think what we add on top of that, distributed tracing is very important because it gives you dependency from service to service to service. I think that's important. What's missing and what we are adding is context information about the full stack, meaning which service runs in which pod on which particular host. So we do not only have what I call the horizontal dependency with distributed tracing, we also have the vertical dependency on the information on which service runs on which infrastructure or which pieces of your Kubernetes cluster. Now, also distributed tracing, a lot of people, when they talk about distributed tracing, they typically start with the first service tier, meaning I don't know, your ingress, your load balancer, your first microservice. We extend it to go outside of Kubernetes to the end user. So that's why the fifth pillar, so beside metrics, log, and distributed tracing, we have the stack information. And the fifth one would be also user experience data. Because in the end, the best performing, let's say, service within Kubernetes, where Kubernetes says everything is healthy and every pod is up and running, doesn't help you if it cannot be accessed from your end users because maybe you have a misconfigured DNS or a misconfigured load balancer somewhere, or if the app itself is just not as the user expects it and therefore they're not happy. So this is kind of the fifth pillar. So we're talking about the three standard, and then on top of that, the full stack information, the dependency information, and also the end user. And with this, we believe you can give better data and also better information about not only is your system up and running, but is it running efficiently, and in the end, is it supporting your business, which is typically your end user or whoever consumes your APIs or your services.
Great. So let's look at some observability use cases for the system you've been describing. Let's start with the infrastructure and platform operators. What are they typically looking for from an observability service, and how does AI help them?
Yeah. So, I mean, first of all, to be honest with you, I'm sure there's a lot of other operators out there that are struggling with Kubernetes on a day-to-day basis that can tell you even better than I can tell you what they like and what they hope AI to solve for them. But what I believe, and again, this is what I hear just from the people that I talk to, is that we have so many more moving pieces that IT operators or platform operators, as we call them, have to look for, right? Instead of having, let's say, your 50, 100, 1,000 VMs, you're all of a sudden responsible for 1 million pods that are running. And you're responsible for a lot of infrastructure that is very dynamic in nature, that is all configured, and obviously through configuration as code, but that is all configured and changes all the time, completely rapidly. And therefore, it's really hard to kind of get a handle of all the changes and also the potential impact it has, because the system is very complex. I'm not sure when it was the last time for you to set up a Kubernetes cluster and you try to configure your ingress and you try to figure out how all this works. It sounds very easy from the outset, from the commercials. Kubernetes solves all your problems, but in the end, it's easy for a demo environment, but it gets very complex very fast if you go big. And this is where I think operators and platform and infrastructure operators look into AI, right? To make sense out of the data for them to figure out which change has a positive or negative impact, and especially the negative ones, they want to be highlighted instead of having to look at all sorts of data logs and configuration changes. I think AI is there to automate the process of figuring out why is the system not in a healthy state, in case Kubernetes itself, for instance, cannot bring the system back to a healthy state on its own.
Yeah, and particularly with complexity, I know developers have a lot on their plate these days, with complexity in their own environment, developer environment, but also dealing with Kubernetes. So how does the AI observability help them?
The apps teams, you mean?
Yes, the apps teams.
Yeah. So, I mean, the observability, as you said, right, we're pushing more and more things over to the development teams. We want to make them more autonomous so that they can deploy their apps in the different environments all the way into production. And if we want to make them responsible, they have to be kind of responsible, obviously, for the whole thing. Hopefully not running and operating Kubernetes, but still everything around it, including all of the different, the service mesh configurations, their canary deployments, their ingresses, and so on and so forth. And this is why it's very important for application teams. They're also no longer just looking at their, and I don't want to diminish their work, but they're no longer looking at the little piece of code that they wrote. But typically, in a modern environment, DevOps environment, developers are responsible end-to-end for their features, and that includes what's happening out there on the end user when they try to access that feature, and what happens from the browser or the mobile app all the way through the different microservices. Where is something going wrong? And instead of just having to, I used to be a Java developer, instead of maybe just looking at, okay, what does this Java exception tell me in case I see it for my little piece, if I'm now responsible end-to-end for the feature, and that involves DNSs, caches, ingresses, front-end load balancers, my microservice, 50 other microservices, then I have to all of a sudden look at so much more data that I might not even be familiar with. And this is where a platform that not only monitors all these data, but also understands the connections and the dependencies and can then highlight, hey, your feature is currently not utilized as you like because one of your dependent microservices is not performing as expected because it runs on low resources on that particular Kubernetes node. These are things where as a developer, I don't want to have to dig into all these different details. I want a solution that is doing observability for me. Tell me if there's a problem, where the problem is, and how I can fix it. And either me or at least telling me where to go to, right? Okay, it's this backend service that is acting up weird. Or somebody misconfigured the ingress. Who misconfigured the ingress? Oh, the AI observability tool should also know who made that configuration change, right? And then point me to the right people to address this problem.
Okay. And so what role does distributed tracing across the entire Kubernetes environment play in reducing operational complexity?
Yeah, I think distributed tracing is at the core of all of this, right? As I said, I think I repeated this story now multiple times. As we're moving towards cloud native or whatever term you want to give it, we're all and moving to DevOps and moving to a state where we are no longer working in silos, but actually creating value teams that are end-to-end responsible for the features. We need to have end-to-end visibility. And end-to-end visibility is possible through distributed tracing. And therefore, distributed tracing is essential for really figuring out what's going on, not only with my services, but all the dependencies. And most importantly, what is happening out there? Why is the service not responding within the SLAs that we thought it's responding? Why are my end users not using it? And therefore, distributed tracing tells me everything that happens from the end user all the way through my distributed application that goes through 1, 10, 50 microservices, different service meshes. Distributed tracing is core here. And fortunately, distributed tracing has come a long way. We at Dynatrace, we've been doing distributed tracing even before I started, and I started 12 years ago. We founded Dynatrace in 2005, and we've been doing distributed tracing in enterprise applications for a while. And fortunately now, obviously, the technology evolved and the industry evolved. The industry also now sees the necessity of distributed tracing, and so many more people are jumping on distributed tracing. We also now see standards coming out, and I think that's great. Everybody's going to benefit from all of it, from this movement.
Great. Well, let's talk now about a specific project in the cloud native space, Open Telemetry. Dynatrace has been closely involved with this project. Can you explain why an observability framework was needed in Kubernetes in the first place, and what value telemetry data brings to operations teams managing Kubernetes?
Yeah, so I think as a standard is always a great thing, right? Because standard means more people can then build value on top of standards if you can rely on something, interfaces, definitions to be there. Because if you don't have standards, then you get a lot of individual solutions that are all relying on an implementation that they build for a certain system so that that implementation keeps working even with new versions coming out. I remember the days when we started with building observability with Dynatrace in like 10, 15 years ago, and we constantly had to basically refactor, not refactor, we had to look into code and figure out how can we actually get data out of it. And we were always hoping that the next, let's say, version of Java and next version of .NET still behaved the same way as the old one did, so that our implementation didn't work. So that means a standard is always a good thing, because that means it gives you stability. It gives tool vendors the stability that they can build value on top of something that they have. Now, why is it important in Kubernetes? Because Kubernetes is a very complex system with a lot of moving pieces. And if we have a standard that defines how can we get observability done, meaning log, metrics, traces, hopefully also some of the things we're doing on top, meaning, as I mentioned in the beginning, the vertical dependency, so the full stack dependency, as well as some things on the end user side. If this is also part of it, this will benefit not only the developers, not only the operators, but also the tool vendors that can build better toolings on top that also again help the developers and the operators. That's why this is so important.
Great. And a robust monitoring platform monitors the state of the Kubernetes cluster as well as the deployed applications. So how does automation help to monitor large clusters with auto discovery, auto instrumentation without code changes, topology mapping, that kind of thing?
Yeah. I mean, in the fear of repeating myself again, right? The reason why all of this is so important is because we're moving into a direction where systems don't become less complex, right? You mentioned it in your question, right? Large clusters. Large clusters means not only large in terms of more CPU, more memory. Large clusters means you can run more workload, more diverse workload, meaning you can run hundreds and thousands and millions of pods that are using different types of technologies, whether it ranges from Go, from Python, from Java to .NET, everything is in there. And this is the reason why we need a robust ability to monitor these platforms and everything that is going on. Because if the monitoring itself is not robust, and you're trusting monitoring to tell you if everything is good or no good, well, if it's not robust, you cannot trust the data that you see. And if you don't trust the data, how would you make any decision, whether it's manual or automated? Therefore, monitoring has to be seen as a critical component that has to be as robust as you expect an operating system to be, or any core component of your system to be, right? Because only if it's robust, you can do all these things that are important, which means you're getting an overview of what's going on, automatically reacting to change. You mentioned, I think, topology mapping, auto discovery. I think this is all important because if you don't know what's going on in the environment, it's hard to say what is missing. We deployed just something, is this really there? And things like that. So that's why this is hugely important. Also, I think you mentioned auto instrumentation too. Auto instrumentation, while you may say, well, why do we need auto instrumentation if we have open source frameworks where developers can instrument their code? That's true. But then go to your Kubernetes operators and ask them how many of their developers are really fully instrumenting their applications in the level that they need to figure out if there's a problem with what's going on. This is why auto instrumentation is also very important. That's why it's great that we have a lot of the vendors in this space that over years have invested in auto instrumentation technology so that you get automatic visibility, end-to-end tracing into what's going on without always having to rely on that somebody can change the code and build instrumentation in. So this is also very important.
Excellent. And so let's look a little bit at the people side of this now. During the research for our new Kubernetes ecosystem ebook, it showed that the cultural changes in development teams due to the rise of Kubernetes have been particularly challenging. And so many organizations now, as you know, have formed DevOps teams, and the developer's role continues to be pulled towards handling aspects of the infrastructure layer. So that's kind of a struggle for them. So as a DevOps activist, do you have any advice for development teams struggling with this issue?
Yeah. So you speak obviously out of kind of my soul or my heart. I've been fortunate enough to see DevOps transformation, or again, whatever you want to call it. I think also DevOps has been over the last years a term that has been stretched too much and misused. But essentially, I think we all understand that what it is, it's not only a change in technology, about automation, it's about cultural change, meaning giving on the more side more responsibilities to engineering teams so that they are again end-to-end responsible for value that they're creating. I think the concept of value creation teams that are then responsible to bring value to market, but not only to market, but also operate it is very important. The cultural change here is, I think, the biggest problems that I've seen that while a lot of organizations say, yeah, this is great, we do this, but still from the top down, you need to have top level management buy-in, because otherwise you never get the trust. If development teams don't get the trust to do all this, and are always kind of monitor them with hawk eyes, and it's like, yeah, you're bound to fail and you're not supposed to fail, then this is obviously not good. In that transformation, failures will happen, things will go wrong, and that's just clear because we're having a dramatic shift in how we do software engineering and how we deploy and how we operate. So I think it's very important that an organization is open and embracing failure and not punishing people, but obviously setting guidelines and say we cannot fail for the next year because then we're out of business. And so obviously there should be some guidance, some mentoring here as well. The other thing is what I've also seen, I think in your question you said, or in your book, and in your question you said that developers are more and more they also need to take care of infrastructure. While this is true, that we have to handle, or developers have to handle more and more of the infrastructure layer. It's a different infrastructure layer than what it used to be 15 years ago. Developers don't have to go to a store and buy new servers, right? Fortunately, all of this can be done through APIs, and thanks to automation and infrastructure as code and configuration as code, this can be handled in a way that is also a little easier for developers because everything can be automated through code. So I think people will get there. There's two more things I want to say about this. I started engineering 20-something years ago, and when I was hired back then as a developer, the role of a developer was clearly something different as if you're now hired as a developer where you're part of a team that is responsible end-to-end for features. So I think maybe some engineers that are still in the mindset that I'm coding and when I'm done, if I go home and I don't care what happens with the code, I think this is the wrong mindset. So I think as a developer, you also want to know, you should have an interest, a vested interest that what you're coding and what you're developing actually has a positive business impact. And I think with getting this, becoming responsible end to end, which includes how is it perceived out there with the end users, it's a great opportunity, because finally we as engineers, we as developers, we get feedback from the people when they actually like the stuff we do. Because in the old days, we only got the software, the support tickets when people were complaining. And now all of a sudden I may get direct feedback and say, hey, our app rating just went up by 2 stars because of the last deployment. Hey, this was my deployment. This is awesome, right? So I think we need to embrace the positive thing. And the last thing I want to say about this, when we talk about cultural change, and people always say culture is the biggest hurdle, I also have seen it in recent times, a couple of times, that this is sometimes just taken as an excuse, where they say, well, we cannot do anything because culture, and that's why. Well, then the people that say that culture is the biggest problem are sometimes exactly the reason for that being the problem.
Yeah, and just further on the cultural side of things, when I started out working on websites for corporations back in the late 90s, the IT team was very separate from what I was doing. I was more on the marketing side of things because that's just where they put the web people back in those days. So like these days, are those kind of the developers and the operators, are they working much more closely together, or are they still kind of siloed?
Well, I guess it depends on how far organizations have come in their transformation. I see it, let's say, in our organization, where our operators, as you call them, right? There are no traditional operators anymore. What these teams are, we call it the ACE team, the Autonomous Cloud Enablement team. They are basically responsible for making sure that the pipelines, the tooling, everything is there fully automated, so that engineers on this particular platform that they own, including the tooling, that engineers can actually use these tools and platforms to get their ideas to the market and operate them. So they're working very closely together. And the interesting thing is the relationship is more like a product-consumer relationship now. The product of the ops team, again, we call it now the ACE team, the Autonomous Cloud Enablement team, their product is a platform, a vehicle, APIs, tools, that they sell as a product to the consumers. And in our case, the consumers are our development teams that are leveraging this product to get their ideas to market. And so you have a completely different relationship between, in the old days, I have some piece of code, throw it over and you run it and I don't care. Two, I have an amazing idea and I know that you guys help me to get this idea out to the market. You know that you guys help me to monitor it, to make sure that the system is healthy and stays healthy, even if we made a mistake, because the platform that you build and provide to me allows me to do blue, green, or canary deployments. And so I can easily switch back and forth. I think this is the big change between the ops and the dev in the old days versus now. We have a product consumer relationship between the platform team and the consumers are the engineers.
Yeah, that's a really interesting way to look at it. Okay, so AI ops is a relatively new term in the Kubernetes ecosystem. Some observability vendors have expressed skepticism about this idea, but obviously the term is used in your marketing and on your homepage, so clearly you're not a skeptic. Can you explain a bit about what Dynatrace means by AI ops and why you think it's a key part of the observability system these days?
Sure. Again, I feel I have explained maybe some of the concepts already earlier and some of the earlier questions, but basically the way we see it is we are on the one side collecting the data around the 5 dimensions that we mentioned, right? Logs, metrics, traces, stack information, and end user information. And especially the horizontal and vertical dependencies, thanks to the tracing and the stack information, allows us, when we are monitoring metrics like response time, user experience, and we see a problem, that we can then not only alert, which typical operations tool do, right? Your monitoring tools do, the alert on some issue. Not only do we alert on an end user impacting issue, but because we have the stack information, the traces information, we can go down to the actual root cause and can take this information impact. So we know who is impacted. Is it one user? Is it a million users? Is it only the users that are exposed to the canary and they know anyway that this is a canary because they opted in for a beta test? Or is it our real customers? So we know the impact, business impact, and we know the technical root cause because everything is connected. Now, having this information available through APIs and through automation also allow us, and this is maybe where the skeptics come in, but this is actually what really works, and the way we see AI ops, we can then automate traditional operational tasks like how can we bring the system back to a healthy state, knowing all the details that our AI solution just told us. How can we bring it back to a healthy state if scaling up alone doesn't do the job, right? If we have a clear issue, a configuration issue, or if an external system is currently failing, or if a new build brought in a problem that cannot be solved by scaling up, but actually has to be rolled back, or if an external system is behaving weird and therefore we have to switch configuration to a different system. These are things that we can automate with our approach to AI ops, getting the business impact, the root cause, and then using this information to automate operational tasks to bring the system back to a healthy state.
Right. And so it seems to me that a lot depends on the quality of the AI software itself. And so obviously with Dynatrace, you're confident that you have the solution that can do all these things that you just described.
Mm-hmm. Yeah, exactly. Yeah, I think the quality, you're perfectly right. It's the quality of data, and quality not only means the high fidelity data, let's say, great metrics on host level or process level. It's also about the connection, the context between how does this data relate to each other? Why is this service up here, or how is this service up here relating to a service 3 tiers down the architecture? And again, this information comes in through distributed tracing and the full stack information. That's also very important.
Excellent. And so lastly, what are some of the trends that you foresee in Kubernetes observability over the next several years? This is a fast-moving space, and you're one of the front runners in terms of how AI is involved in observability. So what do you think is coming down the track?
Well, I think it's going to be interesting because I hope, thanks to all these standards that are put out there, all this new technology, there will be, I'm sure, a lot of new vendor flooding the space. I think it's going to be great to see what new inventions come up thanks to these new vendors. It's also great for us to observe on where we need to head. I think we are on a great trajectory already. We've proven this over the last 15 years that we've always jumped from one technology to the next and kind of being ahead of the curve instead of lagging behind. But I think the next interesting years are, first of all, Kubernetes. While we've been talking about it for years now, I think we're just getting now into the kind of second adoption wave, right? So there's still a lot of people that are far, far away from Kubernetes, or at least, using it seriously in production, even though I know the numbers go up. But I'm pretty sure we'll see more and more people coming into Kubernetes and then seeing the need of observability. And hopefully by the end, the standards and the tooling will be even better, so that nobody is struggling with getting great visibility in Kubernetes and keeping the system healthy. Because if we cannot solve this problem, right, if people go into Kubernetes and say, man, monitoring is just so hard and this is impossible, let's go back to the old days, then this is going to be a hurdle for people to enter Kubernetes. And I think we do our part as Dynatrace, and I know other vendors are doing their part as well. And I'm pretty sure there's some really cool new things coming up in the future.
Absolutely. I'm sure there will be. Okay. Thank you very much, Andreas, for spending time with us today on the New Stack Makers podcast. Where can people find you on the web and social media if they want to discuss these types of topics?
Sure. Multiple ways. You can either find me on LinkedIn if you search for my full name, Andreas.Grabner, on GitHub, on Twitter, and everywhere else. I am Grabner Andy. So it's my last name, GrabnerAndi. So I'm very particular because the short version of Andreas is Andy. And most people write Andy with a Y, but I always do it with an I in the end because I just want to stick out maybe a little bit. So Grabner Andy, that's my Twitter handle, and also my GitHub handle, and most other handles. That's the way you can find me.
Thank you again, Andy, for being a guest today on the New Stack Makers. Again, that was Andreas Grabner, DevOps activist for Dynatrace. After listening to this show, if you've got any thoughts on observability, AI or otherwise, be sure to hit us up on Twitter at the New Stack. You can also find us on LinkedIn and Facebook. We'll see you again in the next edition of the New Stack Makers.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.
Dynatrace is the leader in software intelligence, purpose-built for the enterprise cloud. It's the only AI-assisted, full-stack, and completely automated intelligence platform that provides deep insight into dynamic, web-scale, hybrid cloud ecosystems. That's why the world's leading brands trust Dynatrace to deliver perfect user experiences.